Hi everyone. My apologies, your network seemed to have challenges, so I'm going to help you. I'm going to do the lesson. I'm recording the lesson, then I'll send the recorded lesson to you. So we're going to look at A-level logarithms. That's your P3. I think it's under algebra, your first topic. So for example, we know that 2 to the power 4 is 16. So we can also write log 16 to base 2 is y. Then I can say 2 to the power of y is equal to 16. And I know that 2y is the same, 16 is the same as 2 to the power 4. So y is equal to 16. So in general, from what I've said here, if I say log of a to base a, log of x to base a is equal to b. If you follow what we have done here, what it means, I'm saying x is equal to, I can represent this is very important, x is equal to, follow this, log 16 to the base 2 is equal to 2 to the power of 1. So we're saying a to the power of, this is very important, that's the first thing. Log a, x to the base a is equal to b is the same as saying x is equal to a to the power. So if I say log 27 to base 3 is equal to m. What I'm saying 3m is equal to 27. And we know that 3m is 3 to the power of 3 here. So our m is equal to 3. Then we have the laws of logarithms. Laws of logarithms. So from the laws of logarithms, we know that ln a plus ln b is the same as ln, if I'm adding, I multiply ab. If I say ln a minus ln b, I divide, that is the same as ln a divided by b. If I say ln a to the power of n, this is the same as n ln a. Then another thing in general is that ln e in mass is equal to 1. The ln e is equal to 1. So, for example, if we were to say ln 2 plus ln 3, this is the same as ln bracket 2 times 3 is equal to ln 6. If I say e to the power of x is equal to 6, in maths we are saying ln e to the power of x is equal to ln 6, taking lns on both sides. Then this, you know, this is x, ln e is equal to ln 6. But this is equivalent to 1, so therefore your x is ln 6. Hope it's making some sense. So if we have e to the power of 2 minus x being equal to 10, so how do we solve that? We take logarithm ln e 2 minus x is equal to ln 10. Hi guys. Hi guys.
Hello, sir.
You seem to be struggling with your network. So,
Sir.
yes, you can hear me. I am recording the lesson. That's the good thing. So you catch up but I'll go back.
Hello.
Yes, can you hear me? Can you see my whiteboard?
Hello.
Yes, I can hear you. Can you see my whiteboard?
Yes, sir.
So I'm saying
Yes.
what I had done is I was talking of laws of logarithms. So what I started, I said 2 to the power of 4 just is equal to 16, you know that. So we can also write this as log 16 to base 2 length is equal, let's say, to y. So what we are simply saying here is we are saying 2 to the power of y is equal to 16. Then we know that 2y is equal to 2 to the power of 4. It means your y is equal to 16. So what I wanted to show you is this here. So if I have log a, log x to base a being equal to b, what I'm simply saying, if you follow here, I said 2 to the power of y. So I'm saying a to the power of b is equal to x. That's the first thing that I wanted you to see. Are we together? Clear? Can you guys hear me? Can you hear me? Yes, your sound. Yeah, your sound. I don't know what's happening with your network today. Anyway, look.
Yes.
Yes, your question. So let's look at laws of logarithms. Don't worry, I'll record and I'll send to you at the end of the lesson. Laws of logarithms, if there's something that you're missing. Number 1, ln A plus ln B. So if we are adding here, we multiply AB. And the opposite is true. Number 2, ln A minus ln B. If I'm subtracting, I divide. There is A over B. So number 3, ln A to the power of B is the same as B ln A. That's the other thing that, these are the main laws of logarithms. The rest we are simply applying. So if I say, for example, simplify ln 2 plus ln 3. So because I'm adding, I multiply. So it's ln 2 multiplied by 3 is ln 6. Clear? If I say ln 5 minus ln 4, I divide ln brackets 5 over 4. If I say ln 2 to the power of 3, this is the same as 3 ln 2. I'm playing around with logarithms. So if I have e to the power of x being equal to 5, and I want to solve to find the value of x, I take lns of both sides. I say e to the power of ln x like this is equal to ln 5. Then using the law of logarithms, this is the same as x ln e being equal to ln 5. But ln e, you can find that on your calculator, ln e is always equal to 1. So if it's equal to 1, it simply means x is equal to ln 5. So let's look at another example. If I have e is equal to 2x minus 5 being equal to 10. We want to find the value of that. So we say ln e to the power of 2x minus 5 is equal to ln 10. Then using that rule, ln e is equal to ln 10. Are we together? So in that case, we now know that this is 1 here. So we left with 2x minus 5 is equal to ln 10. Therefore, 2x is equal to ln 10 plus 5. X is equal to ln 10 plus 5 divided by 2. Are we together? Making sense? Are you guys there? Or I've lost it. If I say 5 to the power of 2x minus 1 is equal to 4 to the power of x. And we want to solve this. to find the value of x. So to do that, I take lns of both sides. I say ln 5 to the power of 2 minus x is equal to ln 4 to the power of x. Then remember we said this is the same as x ln 4. This is the same as 2x minus 1 ln 5. Then we simplify brackets here by multiplying everything. So this becomes 2x ln 5 minus ln 5 being equal to x ln 4. Then I take everything involving ln x on one box plus 2x ln 5 minus x ln 4 is equal to take the other on the other side, that is ln 5. Then I factorize here. So if I factorize, I'm going to have x brackets 2 ln 5 minus ln 4 is equal to ln 5, like that. Then mathematically, we know that, so now this is what we have, then we can even divide both sides if we want, so that we find the value of x. So the value of x in this case, I can actually write it like this. This is ln 5, but I can simplify it over brackets 2 ln 5 minus ln 4. But we know mathematically that ln 5 over, this is the same as ln 5 squared minus ln 4. Ln 5 squared is 25. So that is ln 5 divided by ln 25 minus ln 4. So that gives you ln 5 divided by 20. We divide here, ln 25 over 4. If I'm dividing, I subtract, or I can even leave it like that. But now, having said that, so what we want to do is I want to use the paper that I've shown you. So I'll solve some questions, then the rest you can do that as homework. Then I'm praying that next time your network will be perfect, so that we won't have further problems. So just take the paper, the A-level maths paper that I sent you. So this is the paper here with so many questions. So we're going to try certain questions on logarithms. So the section on logarithms is what you're interested in. Logarithms. Logarithms. There we have logarithms. So our first logarithm there is log 10. We want to solve this here in terms of 10. So this is to base 10 here. What we need to know is that log to base 10, 100 is equal to 2. So that's what we apply here. So this becomes log to base 10x plus 5 is equal to log 10, 100 plus 2 minus, so that is the same, log to base 10x. But remember, if I am subtracting, so this becomes log 10 brackets 100 divided by x is equal to log to the power of 10x plus 5. Since they are all the same, we drop the logs, it becomes x plus 5 is equal to 100 over x. Cross multiply, we get x squared plus 5x is equal to 100. Then move this to the other side, it becomes x squared plus 5x minus 100 is equal to 7. So solving that, you can, so then you solve, you look for are there factors that when you multiply, you get 100, when you subtract, you get 5. Or, let's see, I think they said giving the answer. Okay, right, and show that the expression can be written as a quadratic. So the same one that's to show this. Hence, find the value satisfying the equation. The value satisfying the equation. So this is the first part, quadratic. The second part is now to try to see, can we solve it? So there are many ways you can do. If you want, you can complete the square. So if you complete the square, you have x plus half of this, that's 5 over 2 squared, minus, if you square this here, is 25 over square that 4, minus 100 is equal to 7. Then you've got x plus 5 over 2 all squared. Move that the other side, it becomes 100 equal to 100 plus 25 over 4. So that gives you 425 over 4. Then you can solve it. You're not worried by that. What I wanted to show you is how you do the quadratic. Now, the next part, I'm not sure. I think it doesn't look very clear. Then solve. This is not very clear here. Show that y is equal to, when y is equal to that, this can be known, it's not clear. I'll leave it for now. So let's concentrate with number 3. Number 3 is saying we want need to solve this. So to solve this here, I take e of both sides. If I take e of both sides, this drops here, and I have 1 plus x there. Because if I say e to the power of ln a, e to the power of ln a is simply equal to a. So this drops. Then this here is the same as e to the power of 1 multiplied by e to the power of ln x. The x drops there, so 1 plus that is equal to, so this becomes x only. So this becomes exe like this. Then we group like terms together, so 1 is equal to xe minus x. Factor out x brackets e minus 1 is equal to 1. Therefore, x is equal to 1 over e to the power of minus 1. That's your answer. When they want you to be significant figures, you're simply playing with your calculator. Then you find the answer. So the next one is number 4, which looks like a graph. So remember, a graph is a straight line. You can tell there we are thinking of y is equal to mx plus c. Because we are seeing a straight line, but we are not told where it's going to touch. But we've got ln y here. Remember, if your graph is xy, that is where we formed this. But now this is very different. It's ln y, ln x. So now, there's 2 variables y are denoted by a, y is equal to that, where that is equal to that. The diagram shows you that use define the value of a and m. So we are told that y is equal to a, y is equal to a x to the power of n. Let's take lns of both sides. Ln y is equal to ln a x to the power of n. This is the same as ln a plus ln x to the power of n. The second law of logarithm. And this here is the same as n ln x plus ln a is equal to ln y. If you compare with your equation, y is equal to mx plus c. Y is equal to mx plus c. If you remember, c is your where the line is cutting. This is the y-intercept here. And the gradient of this line, which means if I connect my lines, the gradient of that line is n. So I want to use this graphic. I'll use the ruler. because I want to find the y-intercept. I connect my points. Then I also find the gradient. So I want to connect all the points like this. So I've connected the points. Then I now know the y-intercept is ln A. So ln A is equal to, what is that point? These are like 20 points. I'm correct. 1, 2, 1, 2, 3, 4, 5, 6, 7. So this is 0, 0.7. Therefore, take E of that. So it means A is equal to E to the power of 0, 0.7. Or you can find that's the value. Then N is simply the gradient. The gradient, you can pick any 2 points. You do change in Y over change in X. So for example, if I pick that and that point here. So to calculate the gradients, I'm going to say change in Y, N is equal to, what is that point here? 1, 1, 2, 3, 4. 1, 4 minus, what is this point here? 0, 0.7. I want divided by, I'm using this point and that point, divided by, what is the x coordinate here? 2, 9 minus 0. So that becomes 0 0.7 divided by 2, 9. Then you use a calculator. That will be your value of N. Now, given that 4, x is equal to 4, so we're saying x is equal to 4 to the power of 3y. We want to make y, express y in terms of x, making y the size of the formula. So take lns of both sides. So let's do it on a new worksheet. So we're saying x is equal to 4 brackets 3 to the power of y. Then ln x is equal to ln 4 brackets 3y. So ln x is equal to, we are multiplying here, we add ln 4 plus ln 3y. So it means ln x is equal to ln 4 plus 3 plus y ln 3. Then we take that the other side, so y ln 3 is equal to ln x minus ln 4. Then divide both sides, y is equal to ln x minus ln 4 divided by ln 4. So we are done. Use substitution. U is equal to 3 to the power of x, or otherwise solve correct with very significant figures the equation 3 to the power of now there's a typing error. I think that one is a minus. So for now, I would say let's leave it. Some of them are not clear. I'll have to check for you, for example, whether this is 3t or 3x. I'm not sure here. Three to the power of what? that an x what? A 3x. Should be 3x. So I think it's like, it should be like this. E to the power of x plus e to the power of 2x, I think, is equal to e to the power of 3x. So there are many ways you can do it. What you can do is you can say let y be equal to e to the power of x. Remember, 2x here is the same as e to the power of x multiplied by e to the power of x. Also, we add this. So it means this is y plus y squared is equal to y cubed. Then moving things on one side is y cubed minus y squared minus y is equal to 0. Then you can factor out for y cubed. You can factor out y here. Then we have y squared minus y minus 1 is equal to 0. Then in that case, we have y is equal to 0, or y squared minus y minus 1 is equal to 0. Negative 1 is 1 times. So this here we can complete the square. So y minus half squared minus square that quarter minus 1 is equal to 0. Therefore, y minus half squared is equal to negative 1 and a quarter, so that's 5 over 4 square root of both sides. Y minus half is equal to plus or minus root of 5 over 2. Move that the other side, y is equal to half plus or minus root of 5 over 2. But y is also equal to 0 for this here. But that's not our answer, because we said let this. So we said let y be equal to, what we want is x. We said let y be equal to e to the power of x. So take ln of log y is equal to ln e x. Therefore, x is equal to ln y. So if we say ln 0 here, ln 0, get an error. So this is out. Then we can't have ln of a, so the only answer is a positive answer. So it means x is equal to ln brackets half plus root of 5 over 2. Or you can find that in your calculator. So now that's for 6 minutes. Then we have this here. So giving you answer to 3, ln that plus that plus. So we are saying ln brackets x plus 2. Ln brackets x plus 2 is equal to 2 plus ln x. So we can bring the terms involving ln x on one side. Minus ln x is equal to 2. Then we know that mathematically we can divide. Then I can now take e of that and e of that. Then our remaining is x plus 2 over x is equal to e to the power of 2. Then I multiply, that's x e to the power of 2 is equal to x plus 2. Then move that side, x e to the power of 2 minus x is equal to 2. Then factor out x e to the power of 2 minus 1 is equal to 2. Then your x value is 2 divided by e to the power of 2 minus 1. Then you can find from your calculator Maybe one more from last year's exam paper, so that you see some of the actual campus questions that you should expect to get on logarithms. So I'm going to start with the 3-1 paper. So we have 2 to the power of 3x minus 1 being equal to 5 brackets 3 minus x. So we can take loans of both sides. Ln 2 3x minus 1 is equal to ln 5 brackets 3, sorry, 3 minus x. So now this here can be represented as 3x minus 1 ln 2 is equal to ln 5. We are multiplying plus ln 3 to the power of minus x. So that is as good as ln 5 plus minus x ln 3 is equal to, remove brackets here, 3x ln 2 minus ln 2. So then we take, so that's 3x ln 2. Bring this the other side, becomes plus x ln 3 is equal to ln 5 plus, take that the other side, ln 2. When we are adding, we multiply, so this becomes ln 10. Factor out the x here, that's x in brackets 3 ln 2 plus ln 3. Then x, this is the same as ln 2 to the power of 3 plus ln 3 is equal to ln 10. Then this is x bracket ln 8 plus ln 3 is equal to ln 10. So then we multiply here because we are ending. Ln 24 is equal to ln 10. Then divide both sides. X is equal to ln 10 divided by ln 24. Like that. So that's how we do it. This was from last year. It was like 4 months. October, November. So let's look at one more example for a recorded lesson. Loans. They repeated the same classification system. Sometimes they give you difference. These are different variants. Maybe it's because they're just doing the same thing. Maybe let's look for the important thing. Yeah, this looks different. This is different. Giving you answer to 3 decimal places. Giving you answer to 3 decimal. So I would say you can say ln brackets 2x minus 1 is equal to ln brackets x plus 1 all squared minus ln x. So this is the same as ln brackets 2x minus 1 is equal to ln brackets x plus 1 all squared multiplying divide or divided by x like this. Then I raise this to e. I raise this above e. So that I remove the longs. I have 2x minus 1 is equal to x plus 1 all squared over x. Then if I cross multiply, I have 2x squared minus x is equal to x plus 1. Brackets x plus 1. The one the answer 2, 3, just one this. So 2x squared minus x is equal to x squared is 1x plus 2x plus 1. Then this becomes 2x squared minus x squared minus x minus 2x minus 1 is equal to 7. So we got x squared minus 3x minus 1 is equal to 7. Then same completing the square, minus 3 over 2 squared minus square of that 9 squared to denominator 4 minus 1 is equal to 7. Therefore, x minus 3 over 2 squared is equal to 1 plus 9 over 4. 1 plus 9 over 4 gives you 4 over 1, that's 4 plus 9, 18. So x minus 3 over 2 squared. Square of both sides, x minus 3 over 2 is equal to plus or minus the root of 18 over 2. Square root of 4. Check that the other side, x is equal to 3 over 2 plus or minus the root of 18 over 2. So it's learn something, you can take ln of a negative. So x is equal to 3 plus root 18 or over 2. Then you find that in your calculator.